Okay, so this is the third revision video to help you with your physics paper 2. So we're going to be concentrating on springs, and when you think about springs, help us to think about Hooke's law. So to start with, you always need two forces on a spring to extend the spring. And that might sound a little bit confusing to start with, but bear with me, it is quite straightforward to spell spring right. Okay, to extend the spring. Just raise that up a little bit so you can see. Okay, so you need two forces. So imagine that we've got a spring. So there's all the different parts of the spring. We need a force there, and we need a force acting down. If we only had a force acting down, then the spring would just go in that direction. If we only had a force acting upwards, the spring would go upwards. So we need two forces to make sure the spring stays where it needs to stay. Okay? Right. So, mentioned extension. That's really important because you need to know how to work that out. So if you start off with a spring, okay? So there's a spring, and we're going to put some little weights or masses at the end of it. So let's pretend that our spring at the start, before we add anything to it at all, is 2 centimeters. Okay, now we're going to get the spring, and we've added a force to the bottom, and we're going to say, I won't do it like that, I'll just say we've added a 10 Newton force. So now that spring, it was 2 centimeters, but now you can see it's got bigger. So now I'm going to say that it's 3 centimeters. So the extension of that spring is now 1 centimeter. So extension simply means how much bigger it is compared to when you started. So you tend to find that when you do experiments like this, they tend to have meter rulers there, and you look across, that's meant to be an eye, and you can see where these different lines are. Okay, so I've mentioned Hooke's law. So Hooke's law states that the extension of a spring, and this is an important one to remember, is directly proportional, is directly proportional to the force applied. Okay, and I'll just leave a space because I haven't quite finished that. But the extension of a spring is directly proportional to the force applied. So if I plotted that as a graph, we've got the extension of a spring, and we know how to work that out now, and that's measured in meters, and we've got the force that we're applying. So directly proportional, as one increases, the other one increases, it has to go through the origin, and it's a perfectly straight line. But we know if we keep on stretching something and then let it go, up to a point, it won't go back to the way it was. So if I let go of that spring now, it would probably go back to the size it was. But if I put more and more force onto that spring, eventually the shape of the spring will change and it won't go back to its normal size. So we reach a point where force applied, so up to a limit. Okay, I'm going to call that P. And after P, the shape of the curve starts to change. And the limit is called proportionality limit. Proportionality limit. So the extension of the spring is directly proportional to the force applied. So force applied is really not forces, up to a limit, and the limit is the proportionality. It's called the limit of proportionality. Okay, Hooke's law, it's important to remember that the force in newtons is equal to something called K, which, let me write that somewhere with a bit more space. So sorry about that. So force, which is in newtons, is equal to K, which is called a spring constant, and that is times by the extension, which is measured in meters, and the unit for spring constant is newtons per meter. Okay, so it's important to remember that when we're talking about springs and Hooke's law, you always need two forces for the spring to extend. You need to know how to work out extension, which is the change in length at the end compared to how it was at the start. Hooke's law states that as you increase the force, the extension increases, and that's directly proportional. It has to go through that point there that's called the origin. But we get to a point which is called the proportionality limit, where that rule no longer applies. The equation is force in newtons equals a spring constant in newtons per meter times the extension. Okay, thank you very much.